Hello, this is Mr. Stansbury. I'm going to take you through one of the problems on the 16B Part 1 assignment. We're going to take a look here at number 4. An alpaca breeder wants to produce fleece which is extremely fine. In 2015, his herd mean fineness was 20.3 microns. 2019, a sample of 80 alpacas from the herd was randomly selected, and the mean fineness was 19.2 microns. With a standard deviation of 2.89 microns, perform a two-tailed hypothesis test at the 5% level of significance. Determine whether the herd fineness has changed. So, first thing we're always going to want to do with these is come up with our HO and our H1, right? So remember, our HO is that everything is the same, nothing's changing, so our mean is going to equal 20.3 microns, and then H1, and since it's a two-tailed, all we're doing is just trying to figure out if it's gotten either more or less fine, so it's not equal to 20.3. Okay, it's usually a good idea to describe what our two hypotheses are, so I just wrote that down in there. So what we're going to want to do with this thing here is we're going to want to get our graphing calculator out, go into stat, and this is the t-test. So we go over to tests, and we go down to the t-test, and we push enter. Okay, now, the first part here says input, and you're either going to have the raw data or the statistics. In this case, we have the statistics because it tells us the mean fineness was 19.2, and the standard deviation is 2.89. So we're going to do the stats. We'll push enter, go down. Our original mean fineness was 20.3, so that's what we want to measure it against. And then our new mean here with the sample was 19.2. Okay. And then SX here is our standard deviation, so that's 2.89. And then our N is the sample space, the number of sample items taken. So in this case, it was 80 alpacas. Okay, and then since we want to do the two-tailed, we want to do the not equal to. So we'll push enter here, and then we're going to simply go down to calculate, and then it's going to give us all of our lovely information here. Now, what to do with that information? Okay, so this officially was, especially from our notes, that's step 1. Step 2 is the significance level. So significance level is 5%. So we call that our little alpha there equals 0.05. Okay. Now the third step is we go through and we use the calculator to come up with our T and our P, right? So third step, T, in this case here, equals negative 3.40. Okay. And then our fourth step here is to come up with our P value. And that's what our calculator did for us, 0.001. Right. And then our fifth step here is to come up with our rejection inequality, right? So what we're trying to figure out is if the p-value is less than our significance level, then that's when we reject HO and take H1. Okay, so in our case here, our p-value is 0.001, and is that less than 0.05? That is true. So that means we reject HO and therefore accept H1. So that means that the herd fineness has changed with a 5% level of significance. Okay? Okay. We're really basically saying here that we accept that the herd fineness has changed. It doesn't necessarily say which way. We can kind of figure out that it has gotten more fine, but all we're looking for, since it's a two-tailed, that it's not the same as 20.3. Actually, the herd fineness is 19.2, so it's probably less fine. Okay? Okay, if you have any further questions on this, please feel free to ask in class. Thanks.